thank you everyone for being here. I'm Anis Sapkecha, a graduate student in Dr. Hagvardi's lab, and today I'll present how different landscape ground covers responded to varying rates of irrigation and how they impacted the visual quality and the canopy temperature dynamics in the inland Southern California. By the end of this presentation, we'll try to see if an introduced ground cover can perform as good as the native landscape ground cover in terms of the plant quality. We'll also find a region why we might be irrigating less in one of our lawn or garden than the other one. And we'll see some examples of ground cover that maintain the growth and the visual quality even at the minimum irrigation rates. So let me start by describing what are landscape ground covers. They are low-growing shrubs or perennial plants that forms a continuous ground covering. We have learned a lot of importance and the benefits of ground covers in today's presentation, and just to add a few of those, ground covers helps to improve the soil, helps to cool the air, and also have some health benefit as they are in our home gardens and the park. However, to maintain the growth and the health of these landscape ground covers, we need to irrigate, and they consume a lot of water. Just in the United States alone, we irrigate like 9 billion gallons of water every single day for our landscapes. And even in the California, the coast, the inland riverside areas irrigate more or uses more of the residential water than the coastal communities. Our landscape ground covers are already using a lot of water, but their water need is ever increasing with the changing climate. For example, if you see this graph, on x-axis we have days of the year, on left y-axis we have rainfall and the evapotranspiration rate in millimeter per day, and on right y-axis we have temperature in degrees Celsius. So in summer we can see the red bars, we receive little to no rainfall in the summer, while the evaporative loss is very high in the summer. At the same time, we also have a higher canopy temperature. So to maintain our landscape ground covers, we need to irrigate, and those irrigation rates might depend upon the plant species to species, which we are going to find in next few slides. And so how much to irrigate, when to irrigate, and how often to irrigate, it's very important questions. And research earlier were mostly based on the expert opinions and were anecdotal, and there are like a lack of research-based finding that says how much we have to irrigate and for how long for our plant species. So in this study, we are trying to evaluate those things and try to answer for some of the ground covers. So our broad objective is to optimize water use in the landscape ground cover, and our specific objective is to study the effect of deficit irrigation on the growth and the development of landscape ground covers, and to provide the information on minimum water requirements of the ground covers we selected for this study. We did a 2-year study in 2020 and 2021 in a year-old established field in Riverside, California, in a sandy loam soil. The picture on the backgrounds is our research field, where we have multiple ground cover spaces laid out in a randomized complete bulb design, and each plots were irrigated independently and controlled with solenoid valves. And we, as Dr. Hagvardi presented in his presentation, we use a smart irrigation controller to irrigate our plots. So we selected 10 different ground cover species that were either native to California or were introduced. And the ground cover species we have in our study are honeysuckle, jasmine, lantana, buckwheat, saltillo evening primrose, golden bush, ice plant, creeping Australian saltbush, coyote bush, and rosemary. So there are different types of ground covers, and they have a different water requirements. So to study how the irrigation impacts the growth and the canopy temperature of these ground covers, we applied 4 evapotranspiration-based irrigation. So those are 20, 40, 60, and 80%. So we applied 20% of water that plant needs, 40, 60, and 80% of what plant needs. And again, we use the smart irrigation, autonomous smart irrigation controller to schedule our irrigation. And we use 12-inch quarter circle pop-up heads with pressure compensation valve for the irrigation purposes. Before I go into the results section of the results, we have a new ground coverage study is recently started, and my friend Jara, she is looking over these irrigation plots, and we have 4 new ground coverage species. So I'll let Jara to speak for a few minutes and describe what's her research on. Jara, you can come in.
Hi everyone. I'm Zahra Amiri from Dr. Amir Hakmerdi's lab, and today I'm going to talk about an ongoing research study at Agricultural Operation University of California, Riverside. We selected 4 ground cover species, and we planted at UCR, and we wanted to determine the minimum irrigation requirement of these species and evaluate the response of these species when they are exposed to varying rate of deficit irrigation. So 4 drought-tolerant ground cover species were selected, and they are new in Southern California. They were planted at Agricultural Experimental Station at UCR, and we are applying 4 irrigation levels to these species, including 80, 60, 40, 20 of reference evapotranspiration from April to October 2022 and 2023. For irrigation scheduling, we are using a weather-metric ET-based smart irrigation controller. So 4 ground cover species are including prostrate acacia. This species is a woody ground cover with the origin from Australia. African daisy and balbieto are herbaceous ground cover, and they are originally from South Africa. The crappia has a grass form and originally from Japan. We just established these species, and we are applying irrigation treatments for 1 month. So this research study is on its earlier stage, and we hope to present our result for next presentation.
Thank you, Jara. We are looking forward of what you find. So a lot of new and cool studies going on here at UCR Water Lab. We study multiple ground covers and apply different irrigation rates to find the optimum rates for those turf and the landscape ground cover. So after that, so we applied different irrigation rates, and to evaluate if those irrigation rates were effective or not, we have to measure, like quantitatively measure the plant responsive. So basically we use 3 indices to measure how those plants responded to the varying rates of irrigation. The first one is visual quality ratings. We go to the field, capture the pictures, and visually rate those on the scale of 1 to 9. 1 is dead or poor, 6 is minimally acceptable, and 9 is the excellent quality. On top of the visual quality rating, we try to use the green seeker that measures the normalized difference vegetation index. So this is the remote sensing index, which highly correlates with the plant health and vigor and says if the plant is healthy or not. It ranges from the scale of 0 to 1. 0 means plant are dead or is soil, while the 1 is healthy plant. And we also measure the canopy temperature, because the difference in the canopy temperature and the air temperature will help us to determine whether or not our plants were water stressed or not. In the following results, I will be presenting the NDVI and the canopy temperature. We have established a strong relationship between the visual quality ratings and the NDVI. So I'll just be presenting NDVI and the canopy temperature. This graph shows how much water we applied for our 4 different irrigation treatments. The graph on the right shows time of the year, and on the y-axis we have irrigation water applied. So we can see the difference in the water we applied for our 20, 40, 60, and the 80% ET irrigation treatments, and the dotted line is the reference evapotranspiration from the CIMIS weather station. And on the left, we have 4 small graphs that basically shows the run times for our 4 different irrigation treatments, how often and how long we irrigate for our 20, 40, 60, and 80. So this is a complex graph as we are running out of time. I'm going to skip this, but this shows the time. This shows the difference in the canopy temperature and air temperature, and basically it says whenever it is less than 0, the canopy is cool and where not water is stressed. For 2080, we have 2 species that did oil, and for 40, we had 3 species or 4 species that were able to maintain the cool canopy even when we apply less water, like 40% of water. Okay, so in the next few slides, we are going to see how our landscape covers responded to different irrigation rates. So we have a lot of pictures over here, but I'll make sure we follow it. We have 4 different irrigation rates. Each column of picture represents 4 different irrigation rates, 20, 40, 60, and 80. On the left, we have a graph that shows the NDVI for each of the species. For each of the graph, the x-axis represents the date of the data collection. Y-axis represents the NDVI. It ranges from 0 to 1. 1 is better. And each graph has a shaded region, the orange shaded region. So once we establish a relationship between visual ratings and the NDVI, we establish a minimum threshold of NDVI that is equivalent to the minimally acceptable plant quality. So anything or any line that falls in the shaded region means that they were either water stressed or they did not maintain the visual quality of that plant. So starting with the first one, the Saltillo evening primos, so we can see the red and the blue line. Okay, so just to mention it before, so we want to see if a plant maintain their visual quality for all 4 of our irrigation treatments, like when using the less water. So ideally they either have to maintain a continuous line or have to keep going up. So if the trend seems to be downfalling, that means their quality is deteriorating. So for Saltillo evening, we can see the red and blue that falls below the shaded region. That means for 20 and the 40, we can see from the picture, they were not able to maintain the visual quality with those irrigation labels. However, for 60 and 80, as we apply more irrigation, they were able to maintain the visual quality throughout the summer. Lantana, at 2080, they suffer a lot. They almost died. While for 60 and 80, they maintain the visual quality, or they maintain the minimally acceptable threshold for 60 and 80. One of the better species we have is creeping Australian saltbush that was able to maintain the visual quality for all 4 irrigation treatments. See, all 4 irrigation treatments were on or above the shaded region. That means they were able to maintain the visual quality throughout the summer for all 4 irrigation, even when we apply 20 irrigation treatments. And we can see over here, they all look visually same and they all are green. Also, if you notice, for 2 of the species we have, they have a canopy temperature mostly above 100. But for these species, the canopy temperature presented over here are mostly less than 100. So that means it was able to maintain the cool canopy and also uses less water while maintaining the acceptable visual quality. Jasmine, it did suffer a lot from going from second year to the third year. We almost lost 20% plants in our 20 treatments, while it was able to maintain the visually acceptable quality at 80% each irrigation treatments. For honeysuckle, it did well for all four irrigation treatments until mid-August, but after mid-August, as summer progresses, this species, the quality of it reduces drastically for 20 and 40 irrigation treatments, while they were still above the acceptable threshold for 60 and 80. And for buckwheat, this plant did not establish in the first year, so we had to replant it again. So because of that, we have very little data, and we're not able to establish a relationship between NDVI and visual quality. So, however, based on the visual quality alone, buckwheat was able to maintain the acceptable threshold for all four irrigation treatments. Ice plant also did well for our 3 irrigation treatments. However, for 2080, it suffered a lot. Like Dr. Marhart said in his previous studies, some might be drought tolerant, but they may not be heat tolerant. So ice plant can be a good example for that. We almost lost for the 2080 treatments. Another good ground cover species we have is coyote bush. It was able to maintain the acceptable quality and was above the minimal threshold throughout the summer for all 4 irrigation treatments. And we also have a golden moose. It did very well and retained the minimal acceptable threshold throughout the summer for all 3 irrigation rates, 40, 60, and 80. However, its visual quality deteriorated for 2080 irrigation treatments, and which we can see over here. So it's visually appealing for 40, 60, and 80. However, for 20, they are very dry. And the last species we have is rosemary. Again, it did very well for 40, 60, and 80 irrigation treatments, but its visual quality in terms of NDVI deteriorated for 2080 irrigation treatments after August as the summer progresses. And again, we can see for 40, 60, and 80, they are all visually appealing and maintain their plant quality. So what we found from these 2 years of study is irrigation rates, that is how much water we apply, type of the species, basically what type of ground covers we have or we choose, and the time of the season, either it is beginning of the summer or late summer, have a significant effect on the canopy temperature, the growth, and the development of ground covers. So our goal is, or we are looking for some healthy ground covers that uses very less water and maintain the full canopy. So from this study, we found some ground covers. For example, the creeping Australian saltbush and the coyote bush, among many others, they were able to maintain the acceptable plant growth even with the minimal acceptable irrigation rates we applied. So the major takeaway, can we introduce ground cover that perform as good as the native landscape ground covers? The answer is yes. For example, the Australian saltbush, creeping Australian saltbush, and the golden bush, they are introduced one, but they were able to maintain the plant quality and the canopy with very low irrigation rates. Why we irrigate less in one lawn or the garden than the other? It might be because of the selection of the species. Depending upon the type of the species we choose, the irrigation demand differs, and we might have to irrigate more or less. So we need to determine the plant-specific irrigation rates. And some of the examples of ground cover that maintain growth and the visual quality even at the minimum irrigation rate. So based on our studies and based on the plants we have, the one is creeping Australian saltbush over here, and the coyote bush, and these two maintain the plant quality even at the 2080 irrigation treatment. And also On top of those can be the gold limobus and rosemary. They were able to maintain the visual quality at 40 and above irrigation treatments. These are some references, and with this, I would like to thank everyone for listening to this presentation, Dr. Agwardi for his supervision.